Jan to all. Today, my topic is a direct method for regular expression conversion to the deterministic finite automaton. So, basically, whenever we will move to convert a regular expression into the DFA, there is a three techniques. First one is you have to take the regular expression. After that, you have to construct the NFA with lambda move or epsilon move by using the Thompson construction methods. Thompson construction methods, or you can say clean theorems part 1. The same synonyms will be used there. After that, you will convert this NFA with epsilon move to the NFA without epsilon move, and this NFA can be converted into the DFA using subset construction algorithm, and after that you have to minimize that DFA. So this particular conversion require a lot of computational cost. Another thing is that you have to minimize the DFA. So whenever you will convert the regular expression into the DFA, it will have a lot of equivalent as well as unreachable states inside the particular transition diagram of a DFA. Second method is that you have to convert the regular expression into the NFA with epsilon move using the Thompson construction methods. After that, you will directly convert the NFA with the epsilon move to the DFA using subset construction algorithm that provide you the way to convert the NFA with the epsilon move to the DFA. And after that, you have to minimize. So the same problem can occur with this conversion also. So we will move a smarter methods or efficient methods that convert the regular expression into the minimized DFA directly. So today we will discuss about this particular methods. So now we can move towards the direct method to the convert regular expression to DFA. Aho, Sethi and Ullman proposed an algorithm that is used to efficient conversion of a regular expression into the DFA. Basically, this method, firstly, in this method, the first step, we construct the regular expression by augmenting it, right? So firstly, we augmented the regular expression by providing the preprocessor sign, right? Or you can say hash sign. So what is the meaning of using this hash sign? Basically, this hash sign is used to provide the final states, right or not right? Whenever you will construct the NFA with Thompson construction methods, the final state will state that have no outgoing edges. Similarly, whenever you will start from the hash, you will append the hash at the end of the regular expression. It will provides the simulation of the final states. So the state corresponding to the hash will be treated as a final states. Due to that, we will append or we will augment the regular expression. So here, if you are giving the regular expression R, it will provide the regular expression by augmenting with preprocessor directive or hash. For example, suppose I have taken this particular regular expression, this A oblique B star A B B. So after augmentation, it will be looks like this one, means you will append at the end hash sign. After that, in step 2, what we have to do, we have to construct the Centex tree for the R hash, right? Augmented regular expression. We have to construct the particular Centex tree. So to construct the Centex tree, or this Centex tree is also called the expression tree in data structure, right? So Centex tree, whenever we will construct the Centex tree, what we have to do? We have to take care of precedence. So in regular expression, only 3 operators are allowed. First one is the clean star, second one is the concatenation, and third one is the union. Or you can say this one is a plus, denoted by the slash or plus. Some author use the plus for the union. So star have a single child and have a higher precedence, highest precedence, not a higher, it is a highest precedence. The next level of precedence is given to the concatenation. It has a 2 children, right? the concatenation operation can perform between the two expressions. So due to that, in Centex tree it have a two children. Third one is the union or a plus operator that have a least precedence and used for the two children also. In the Centex tree, the leaf node basically including the hash sign will be denoted by the string symbols, input symbols in the string of the regular expression to whom you want to the Centex tree. And basically in the Centex tree, what we have to do, we have to assign a position number, a position corresponding to the each symbol in the leaf node of the Centex tree. So basically position value is a number, it is an integer value. So what we have to do, you can see, basically I have taken the particular expression a oblique b star, after that a b b. So whenever we will convert it into the Centex tree, a higher precedence is given to whom? Higher precedence is given to the brackets firstly. So this will be looks like, meaning is that the symbols will always at leaf and operator is the interior nodes, right? So a, after that you have to write down here b, and operator will be slash, or you can say union. After that you have to perform what next precedence is for the clean closure. So it will perform the clean closure operation. The clean closure operation basically have a single child. So this is a complete single child for that. After that you have to perform the first concatenation, because concatenation is a left to right associative. So you have to perform first this concatenation, after that this concatenation, after that this concatenation. So these symbols, these figures looks like this one. If you will augment this one, then last concatenation will hold hash symbol, right or not right? So this is a complete this is a complete Centex tree. Now you will assign the positions value corresponding to the characters or corresponding to the leaf nodes. So this is the 1, this is the 2, this is the 3, this is the 4, this is the 5, and this is the 6. Now this complete representation is used to find out the various operations to construct the DFA. Next, we need to evaluate the basically 4 functions. First one is the nullable, second one is the first position, third one is the last position, and fourth one is the follow positions. So let us discuss each and every one by one. Basically we will start from the nullable. So nullable returns true and false value. Meaning is that if the empty string is the member of string generated by a sub expression rooted at n, right? For example, if we can say you are at this particular point, right, and it will generate so many this. If this particular points, you can see certain portion, this is a root n, right, or subtree that is rooted at n. So this particular, this part of Centex tree generate us expression. If it will generate a particular null string, you can say it will generate, it is have a capability to generate a null string, then we can say the nullable functions return true, otherwise it will return false, right or not right? For example, if there is a only, you can say lambda is a member of a regular expression, then it will returns true for the nullable functions. So nullable of epsilon or lambda will be true. If it is a terminal symbol, then it is a false, right? It is just not true, it is a false, sorry. it is a false, right? If you will think about the operator symbols, so nullable for plus, meaning is that if it is the child C1, this is a child C2, this is a plus operator or slash operator, then if any one of these childs, this one or this one, nullable, right, meaning it will return true and it will return false, then this will be true. It will return false, it will return true, then it will again true, it will true, it will true, then it is true, it will false and it will false, then it will return false. Meaning that for the union, if any one of the child, at least one child is nullable, then you can say the entire expression for nullable plus is null, right? It will generate the null value, right? So nullable plus you can say will be true. If you will think about the concatenation, then in case of concatenation, this symbol will be looks like this one, C1, C2, and concatenation, right or not right? So if it is nullable, means it returns a value true, it will returns a value false, then the concatenation value will be false. It will false, it will true, right, means it will not nullable, it will nullable, then it will not nullable, right? Whenever both are true, then it will return true, means that means concatenation will be nullable when both the child are nullable. If you will think about the clean closure, right? So clean closure by itself generate lambda. You can see if I have written in this manner A star, then the first member is lambda, empty string, right or not right? So by default it is nullable. So clean closure is by default nullable, right or not right? Now we will move towards the first position. So what is the first position? The set of positions of the first symbol in the string generated by the sub expression rooted at n is written by this function, right or not right? So whenever you will think of single terminals, the first position of A will be the integer assigned to it, means the position value that is assigned to the particular A in the Centex tree. If you will find out the first position of epsilon, so it is phi, it is empty, right or not right? If you will think about the first position of star, right, you can see this is C1, suppose. So if you will find out the first position of this, then it is dependent on the first position of this, right or not right? So first position of the child will gives the first position to the star whenever you will think about the interior nodes, right or not right? Whenever you will think about the first position of plus node, so it will be the it will has a two childs, C1 and C2. So you can see if it will contain A, right, suppose, and it will generate a string B. Now you will take the union. So the first position is occupied by either A or B, right or not right? So the first position of plus will be what? First position of C1 union first position of C2, means any member of C1, C2 will be there, right? If you will think about the first position of concatenation, so it is a very good concept here. If you will take the concatenation here, right, C1 and C2, what happens? You can see. Let's first position of C1 is this one, of C1, or first position and C2 of C2, right or not right? Now if you want to find out the first position of this, if this particular node generate nullable value, means it is true, nullable value of C1 is true, suppose, right? Then what happens? It have a capability to generate the epsilon value. When this epsilon value is generated, what occurs at the first position? So this particular things will occur at the first position, right or not right? If it is the epsilon, then first position and last position will be epsilon, right? Nothing. You can say from here, first position is nothing. Similarly, last position is nothing. So the first position will be occupied by the first position of C2. Otherwise, if it is false, then first position will be occupied by what happens? This one. So what scenario you can see from here? If it is epsilon, then it will also be at the first position. So from here you can see, if nullable C1 is equals to true, then what happens? First position will be acquired by of this particular member. First position will be the first position of the C1. If it is means it have a capability to generate the epsilon, then if it will produce the epsilon, then it will also dependent on this one. I have earlier tell you. So union first position of C2, right or not right? Otherwise, if it is false, means C1 is not a nullable, then it will be dependent totally on the first position of C1, right? The vice versa is true for the last position. So last position is the set of positions of the last symbol in the string generated by the sub expression rooted at n, and right, and is returned by this function. For example, if you will think about the last position of a terminal symbol, so the value, integer value assigned to that particular terminal in the Centex tree will be the last position value, right or not right? If epsilon will be the member of a Centex tree, then last position is null, right? Empty set, nothing will be the first and last position. If you will think about the interior node, so last position of star, right or not right? Last position of star, suppose this one, will be dependent on if it is the first position and it is the last position. So this star last position will be dependent on this one, right or not right? So it is dependent on last position of C1, right or not right? Yes, because it will alternatively iterate the same term. So the term this one, when comes at last, right, means the symbol for the C1, regular expression corresponding to the C1 will be iterated so many times. So the position of the last held by the C1 will get repeated at the last in the clean star, right or not right? Okay, now we will move towards the last position of plus. So basically, if you will think about the plus, this is a member C1, this is a member C2. So last position will be held by this one and this one. So if I have written a string for C1 is AB, so last position will be B. If I have written a string for C2 BA, so last position is A. Now you will take the union. So what is the last position? It may be B, it may be A. So last position of this one will be dependent on the union of last position of both C1 and C2 child, right or not right? Once again, for the concatenation, you can see this is a concatenation symbol, this is a C1, this is a C2. What happens? If last position of this one is here and last position of this one is here, suppose, what happens if you will perform the concatenation over here? If it is nullable, right? If it is nullable, then the value of last will be dependent on either, if it is not null value, then it is, if it produce the epsilon, because it have a capability to produce, it is true, nullable, it have a capability to produce the null. If it will produce the null, then last value will be dependent on this one, because the first and last position corresponding to epsilon is nothing, right or not right? So if it will produce the epsilon, then nothing will be first and last position. So the entire expression, the last value will be dependent on this one now. So by the formula you can see, if nullable C2 is equals to true, then the last position will be dependent on both last position of C1 union last position of C2. Otherwise, it will dependent on C2. Right or not right? This is a summary chart. So you can see leaf will contain epsilon, then it is nullable, and the set first position and last position is 5 5. Leaf node will be at I, then nullable is false, means it is not nullable, and the first position is I and last position is I. If you will think about this one union operation, then it will dependent on nullable will be dependent on the nullable of C1 or nullable of C2, means any one of two childs gets nullable, then you can say it is nullable, otherwise it is not nullable. The position, first position will be dependent on the both childs, so first position of C1 union first position of C2, and last position will be the last position of C1 and last position of C2. Similarly, if you will think about the concatenation, so nullable will be dependent on nullability of the both childs. If both childs are nullable, then you can say the result is nullable. So you will take the end operation over here. First position will be dependent on the nullability of the C1. If C1 is nullable, then you can take the union of first position of the both childs. Otherwise, it will depend on the first position of the first childs. Right or not right? Similarly, for the last position, if C2 is nullable, then you will take the union of the left child as well as right child, means both childs, last position of the both childs. Otherwise, it will dependent on the last position of the second child, right? For the clean closure, what happens that it is always generate the null value null string, so it is true. The first position is dependent on C1, first positions means the first position of this one, this particular child, and the last position will be dependent on the last position of the particular single childs. Right or not right? Now we will move towards the same we can say Centex tree A oblique B star A B B has. Right or not right? So this Centex tree can be decorated in this particular manner. Suppose this is a terminal symbol, so what is the left means first position? You can say first position will be dependent on the position of this particular, so it is 1. And what is the last position? It is also 1, right? Is it nullable? No, so it is false. Right or not right? Because I have already tell you the single terminal is never be nullable. Similarly, for this one, the position is 2. So what is the first position? So first position will contain this position. And what is the last position? So it will be 2. Once again, for this third position A, the first position is 3 and last position is 3. Once again, for fourth position B, the first is 4 and last is 4. Similarly, so for all terminals, means all leaf nodes, you can easily compute the first and last. You can see for here, it is 5th, it is 5th. For this one, it is 6th, it is 6th. Right or not right? So this is the first position, this is the last position. Now compute the first and last position for the interior nodes. So you can see for here, this will be the union operators. So the first position will be dependent on first position of C1 and first position of C2. So what is the first position of C1? 1. And what is the first position of C2? 2. So the first position of union operator will be 1 and 2. What is the last position? So the last position will be dependent on last position of C1 and last position of C2. So what will be the value? You will take the union of both. So 1 and 2. Right or not right? Now once again you will move towards the particular points, right? So firstly you will check this is nullable or not. It will generate the null string, so it is true, right? It is nullable. And what is the first position? So the first position of the single child, this is a child C1, will be the first position of star. And what is the last position? The last position of the child will be the position of this star, right or not right? Last position of this star. Now you will move towards this particular point, right? You can see. It will tells you, whenever you will find out the first, if C1 is nullable, right? Nullable C1. It means C1 is nullable, means so here C1 is nullable, right or not? It is true. It is nullable. So what happens? You can see, you can determine you can determine first position of this one union first position of this one. Means first position of this can be determined by the help of a first position of C1 and first position of C2. So it is the 1, 2 and 3. You will take the union and it will get the value 1, 2, 3. Now you can see whenever you will find out the last position, you can see the C2 is nullable. So C2 is not nullable because it is a terminal. So it is, this value is false. This value is false. So once again you can see it is totally dependent on the particular last position of the C2. If it will be the true, then what happens? It will dependent on the last position of this one union last position of this one. But it is a false. Due to that, I have written here 3. Now you can see it is true. It is false. So what is the nullability of this one? It is false, right? Both the child is true, then it is true. It is nullable. So now here it is false, right? You will come to this particular point. This is nullable or not? So single terminal is not nullable. You can find out once again. You can see what is the value of first position value of this particular concatenation. So the first position value of this concatenation will be dependent on the first value position of this particular child. If it is null, then it is dependent on this one also. So here it is not null, right? So you have to copy this one. Means you have to take the copy from here because it is not null. Nullable, it is not a nullable value, right or not right? False value will be here. What is the last position? So you can see the second child C2. This is a B is a second child of C2. If it is nullable, then you will consider this value also. But here it is false. So you will consider this particular last position value of the C2 only for the find out the last position value of the concatenation. Now you can see this is false, this is false. So the nullability of this one is false, right or not right? Once again you will come for here computations. So what happens? This value is true or false, nullable or not? So I earlier told you this is a false value, right? Because it is a terminal. Now you will compute the value. So what happens? This value, the first value of this one, first position value of this one will be dependent on this one. So you will directly copy it because it is not null. Otherwise it will dependent on this one and this one. If this will null. Similarly, false value will be dependent on last value, will be dependent, last position value of this can be computed by the help of this one, right? Because it is not nullable value. So you have directly copied it. Same process will be continued for this one. What happens? This is false or true? It is false. So you have to copy this one. If you will think about that, this is a symbol terminal, so it is false. So you can directly copy it to the last position, right? Now we will move towards the follow positions of I. So follow position of I is defined as the set of positions that can follow the positions I in the Centex tree, right? So follow positions is computed for only terminal symbols, leaf nodes, right or not right? It will be computed for the leaf nodes that are labeled with the input symbols that constitutes the language of the regular expression. So how can we compute the follow positions? So you can see we can compute the follow positions by using two operators. First one is the concatenation and second one is the clean star. You can see only two operations can be considered to compute the follow positions value. If n is a concatenation node with leaf child C1 and right child C2. With left child is C1 and right child is C2, right? You can see C1, C2, right? And I is a position in last position of C1, right? So if I will be the member of this one, right? You can see, then all positions in first of C2 are in follow position of I. So for all the positions in first of C2, this is a first of C2, will be follow position of I, right? Will contain all this, all these values, right or not, right? Will contain all these values. Second thing is that if n is a star node, has a child C1, then all the member, right, in the first of C1 will be follow of I. Means if you can see last position of C1 will contain I, then all the members of first of C1 will be in follow of I, right or not, right? Because you will be here, it is I, and you can see here this is the first position, right? So all the member of first position will be the follow of I for the concatenation operation. So you can see from from here, this is an algorithm. How can we compute the follow? Basically in a Centex tree, I have earlier told you how can we compute. So you will move towards here. So you can see, you can consider the particular this operator, this operator, this operator, this operator, and this operator. You will find out the you can say follow positions. So at this particular point, is बंद कर दूं? Okay, in next lecture we will discuss. हाँ, तो बस 2 मिनट में कर देता हूं, right? So now you can see from this particular position, you can find out the value of this particular follow position. So you will consider the last position, right? So 1 and 2 is the member of the last position, right? 1 and 2. So all the members corresponding to the first position, right, will be in follow position of I. So what is the I value? Here I is the 1 and 2. So 1 and 2. So you will compute the follow of 1 and 2. It will contain the member 1, 2 and 1, 2 as per as this particular set, particular clean closure node, right? You will be here, then you will think, you will move the child, right? So the follow of 1, 2 means any member child last position of the C1 will be the member of this one, first position of the C2. So here the member is 1 and 2. So 1 and 2 you will include 3. So I have included 3 over here. Similarly, you will move for this one. So what will be the 3 contain the member 4. So follow position of 3 will contain 4. For this one, you will move to particular this point. So 4 will contain 5. So the follow position of 4 will contain 5. Similarly, at this one, you can see 5 follow 6. So it will 6. After that, 6 will contain nothing. So you have put it down dash. Now, how can we construct the DFA? So we can construct the DFA by using the set of states of the DFA and D transitions. The D transition tables is denoted the transition table for the DFA. So we start with the DFA-D, first position of the root. So what is the first position of the root here? It is this one, 1, 2, 3. And after that, how can we find out the states? So you can see this will be the starting states of the DFA. The first position of the root is the starting states of the DFA. After that you will compute. How can you compute? Suppose this is the A, B, A, B, B. So you will find out 1, 2, 3, 4, 5 and hash will contain the 6 value, right? Then sequencing will be of this form of the terminals. So whenever you will take the first position 1, 2, 3 and you have to find out the D transition corresponding to A. So what is the value? You have to find out the positions from here that contain A. So you can see at 1 A is available, at 3 1 A is available. So 1 3. You have to find out the follow position of 1 union follow position of 3, because A is available at 1 position and 3 position. So you have to compute the follow position 3. So what is the follow position of this one? You can see 1 and 3. So it is 1, 2, 3 and 4. So this state is 1, 2, 3, 4, right or not right? So at starting state 1, 2, 3, it will moves on A 1, 2, 3, 4. Similarly for B, you can say D transition 1, 2, 3 and B. What will be the value? You can see 1, 2, 3 at B. So at which position B is available? So it is 2. So you can find out the follow position. You will identify the positions at which B is available in the expression and take the follow of that, or if multiplicity will be there, then take the union of the follow of that. So follow positions of 2 will be 1, 2, 3. You can see it is 1, 2, 3. So 1, 2, 3. Now new state will be this one. So you can take this states and find out the transitions. So ultimately this is an algorithm to perform this task. You will get this. Dekhiye, on 1, 2, 3 A, you will move towards the 1, 2, 3, 4. At B, where you will move 1, 2, 3. From 1, 2, 3, 4 at A, you will move towards the where 1, 2, 3, 4. And after B, you will move towards the 1, 2, 3, 5. And after that, you will move towards the 1, 2, 3, 5 to A. You will move towards the 1, 2, 3, 4. And at B, 1, 2, 3, 6. And so on. So it is very easy to find out the transitions. The position of the hash will gives you the final states, means the position of hash is 6. So the states those contain 6 will be treated as a final state. So this state will contain 6. So it will be treated as a final states. So this is a references to follow. Thank you.